So good morning, folks. Jennifer Deal usually does this, but Jennifer, I think stuck in a meeting right now. So I want to welcome all of you guys again. This is obviously our monthly seminar. Today we're thrilled to have our next door neighbor, actually in the sub basement of the 2024 building, Adam Spira, come present to us. And Adam, as many of you know, has collaborated with a bunch of us over the years, in particular Kenning for many, many years. So we're thrilled to have a neighbor present to us as opposed to someone coming from far. A couple of groundkeeping rules, as we always know, for those who are online. There will be a Q&A after presentation. For those online, you can pop and ask questions, and we'll ask questions afterwards for you. There's closed captioning, as always. The seminar is being recorded. This is always sort of fun. So this is the last several months of who we've had over the years. Next month will be our final regular seminar speaker, was Jeanette Mahoney, who just actually moved to Stony Brook recently. Who I think many of you know has done some really, really nice work looking at sort of brain aging and sort of some cognitive training or cognitive testing sort of paradigms too as well. She's worked with us a lot in the past in GSA and various seminars. And then that'll be our last seminar of the year, except until we get to Cochlear Center Research Day, which, as you guys all know, is sort of our one sort of key event. We are doing it differently this year. We're actually streamlining it this year. So there's only going to be one keynote followed by a poster session and a super fun dinner, as always. But we're not doing the whole morning sessions. I think it's sort of past its course. We used to do that, but I think it's sort of changing now several years into the center. And then that'll be Laura Nyblade coming from RTI International. I think she's actually local. She's just down in DC, actually. She's based at RTI there, who's done some really, really nice stuff that we'll hear about then. So Adam, I don't even have your bio, Adam.
Actually,
so
Kenny is introducing Adam.
Oh, Kenny introduce Adam.
Yes.
Oh, come on, Kenny. Come on up.
Kenny.
Oh,
and
good.
while we do that, I just want to make a quick note for us in the room here and online. I know it's a bit dark. Our lights are in the works. So we have some mood lighting for today. So I apologize for it not being super. Please don't fall asleep. We haven't had lunch yet, so maybe that's a good sign. But I do just want to mention that. Apologize. And then Kenny, please take it over. And just a quick reminder again, we're in 2024 for lunch and training Q&A today.
Well, I'm not prepared to introduce a faculty member. Today we have Dr. Adam Spira, and Dr. Adam Spira is a professor, the vice chair for research and faculty in the Department of Mental Health at the Johns Hopkins School of Public Health, and he has a joint appointment in the Department of Psychiatry and Behavioral Science at the School of Medicine, and also a core faculty of the Johns Hopkins Center on Aging and Health. Dr. Spira's doctoral training was in clinical psychology, and he completed postdoc training in geriatric psychiatry research and epidemiology. His research focused on the association of sleep disturbance with cognitive and functional decline and AD dementia. He joined the Johns Hopkins faculty in 2008, and in 2009, he received a Career Development Award from the NIA to investigate the association between sleep disturbance and functional decline in older people. Since then, he has led or co-led multiple grants from NIA investigating associations of sleep and or circadian rhythm disturbance with brain health outcomes, including AD biomarkers. Thank you, and welcome.
Thank you so much.
I almost forgot to get up and come. I was just sort of sitting there.
enjoying
Yeah, it was very nice. Thank you. And so I have until what time? Well, you want to give me 45-ish, 40 to 45 minutes, I think, right? So we're talking like 1:20-ish.
We're gonna end at
No.
1:20, about 1 o'clock.
1 o'clock. Yeah. 1 o'clock. Okay, perfect. All right. Perfect. Thank you. Thanks so much, Frank and Kenning and Mindy and everyone. I really appreciate the introduction. And I'm here to talk about sleep, aging, and brain health in later life. And I added this subtitle and maybe a little bit about hearing. So I'm putting that at the end, so you all stick around. Here are my disclosures briefly. And I'm going to start by saying something that may be, you're all probably aware of this, given the focus of much of the work of the Cochlear Center, but the US population is aging. And I'm going to skip everything else I would normally say because I tend to say more than I need to. Yeah, this is an efficiency thing. So let's talk about what this has to do with sleep. So sleep disturbances are common in older people, and poor sleep is increasingly being linked to poor later life health outcomes, including cognitive decline and functional decline, and Alzheimer's disease pathology in the brain, and other brain pathologies, actually. And sleep disturbance across the life course often is treatable. It's something for which we have really effective treatments. And so there's people are very interested in sleep disturbance as a risk factor for poor cognitive outcomes and just poor outcomes in general in later life. And just how common are sleep-related symptoms in older people? Well, this is a study that I pretty much always show because I think it really makes the point. This is a study, a community of community-dwelling older adults, more than 9,000 from 3 communities. They had a mean age of 74, and more than 80% endorsed a sleep-related symptom, either sometimes or most of the time. And when they looked at endorsements of having a sleep symptom most of the time, which they called a chronic symptom in this study, you can see across the bottom, this is the percent of the sample who endorse having one of these most of the time, and going across trouble falling asleep or waking up during the night, et cetera. And there are others as well, not listed here. 57% said they had one of these at least most of the time. And so this begs the question of why, what's going on with sleep as people get older. And so multiple things are happening here, multifactorial etiology, okay? So there are some changes in sleep that appear to occur across the life course that occur in the absence of disease. One of the things that we know about aging is that generally speaking, you will, if you look in populations, at least in the US, you tend to see an accumulation of chronic medical illnesses. But if we look at people who remain relatively healthy as they get older, we still see certain changes. Those include a shortening of sleep duration, fragmentation of sleep, and spending less time in slow wave sleep, deep sleep, which is the most restorative sleep stage, and spending more time in lighter sleep stages. We also see a decrease in sleep efficiency across the life course. So sleep efficiency is the proportion of time in bed that you actually spend sleeping. And that tends to decline as we get older. Most of these in normal aging, I'm putting this in quotes, based on the best data we have, which is not longitudinal across the life course, which is a limitation of the field. We have a lot of studies, basically a lot of cross-sectional studies and some longitudinal studies of sleep, but across the life course. But most of these changes occur by age 60 or 65, and then people's sleep stabilizes. But that's looking at the healthy population. We think that the high prevalence of sleep-related symptoms that I reported on the last slide is largely attributable to medical and psychiatric disorders and medications taken for those disorders that people accumulate as they get older, oftentimes. There are also decreases in physical function. We know that first, exercise is good for sleep to the extent that you can engage in physical exercise. That should help your sleep. If your physical function, if you have some limitations, that can not only inhibit exercise or stand in the way of exercise, but it can make for more opportunities for sedentary behavior. And I don't know if any of you have ever found yourself sedentary, maybe the TV's on, and happen to have dozed off. There are opportunities for dozing that occur when one is sedentary that are less likely to occur, we believe, when you're not. Also, psychosocial changes occur as we get older that can affect sleep. There can be bereavement as people lose parents, spouses, other family members, other loved ones. There can be retirement. Retirement can actually make for more sleep potentially, but what we also see is that there is a loss of a routine in some people who retire. And then there's more opportunity for daytime sleeping, more opportunity for napping. We know in older adults, we see more daytime napping than in younger people for various reasons. And those things can lead to actually poor sleep at night. There's a homeostatic drive to sleep that builds from the moment that we wake up in the morning until we next sleep. And it's like a balloon that's inflating, right? And there's more and more pressure to sleep. When you nap, you are letting some air out of that balloon, and then you might have insufficient sleep pressure to carry you through the night. So psychosocial changes, also caregiving responsibilities. We talk, caregiving is a huge phenomenon in the United States. And those responsibilities can affect sleep if you're up caring for someone, or because they happen to be up and they're keeping you up, even if you're not providing care. Changes in circadian rhythms. As we get older, so let me back up. So circadian rhythms refer to processes that occur, in many, many aspects of our physiology that oscillate or fluctuate or alternate approximately once every 24 hours, circa, diem, circadian. And those are under the control of a clock in our brains called the suprachiasmatic nucleus, or SCN. And for reasons that are not entirely clear, as we get old, and these include things like core body temperature fluctuates in this manner, hormone release, gene expression, and also the sleep-wake cycle, the alternation of sleep with wake. That's probably the most obvious one to us. That's an expression of the circadian rhythm. And these things all occur even in the absence of any environmental stimulus to entrain them. The term is Zeitgebers, time givers from the German. And it's that we use to refer to these cues. And all of these things will continue to oscillate on this roughly 24-hour cycle, even in the absence of those cues. And that's what makes them circadian. When we get older, we get sleepy earlier in the evening, and we go to bed earlier as a rule, okay? And we wake up earlier. And that's called a circadian phase advance. And people can be dissatisfied with their sleep because they're actually waking up really early, even if they are getting an adequate amount of sleep, which is a whole other conversation, is what's an adequate amount of sleep. And then finally, sleep disorders increase in their prevalence as we get older, such as sleep-disordered breathing, which we'll talk about more. Now I'm going to shift to talking about sleep and Alzheimer's disease. So Alzheimer's disease, or AD, is the most common cause of dementia. And it's characterized in the brain neuropathologically by these extracellular beta amyloid plaques that aggregate early in the course of Alzheimer's disease. And later on in the AD course, we see intraneuronal neurofibrillary tangles. And in 2024, there are 7 million adults aged 65 and older who have Alzheimer's disease. But the prevalence of AD is going to quadruple from the year 2000 to 2050 globally, which is really remarkable and concerning because we have no cure. We have no cure for AD, so prevention is critical. Historically, when we talked about links between neurodegenerative disease and sleep-wake disturbance, let me see if I can get on this screen. There it is. And yeah, that's fine. Let's use that. So we talked about it in the context of people who had Alzheimer's disease, because that was the most obvious link that was apparent to folks in the field, particularly clinicians, because people with moderate and worse Alzheimer's disease have really significant sleep-wake disturbances. So this was really the way people thought about this link between sleep-wake neurodegenerative disease and sleep-wake disturbances, that the sleep-wake disturbance was an expression of this neurodegenerative disease, okay, or a consequence of it. So a few minutes ago, I talked about age-related changes in sleep and what those look like in terms of normal age-related changes. And what we see in older adults with Alzheimer's disease and related dementias, I should say, compared to those without, is those with AD have shorter, more fragmented sleep, lower sleep efficiency, and reductions in slow wave sleep and REM sleep. So really, it's sort of it's analogous to the changes that we see across the life course. They're just accelerated or exacerbated, I should say, in people with AD. And what you can see here is these are readings from accelerometers looking across a 24-hour period. This is purely illustrative and anecdotal. This is a patient with dementia. And you can see that if you look at the movement across time, there are very few periods with any consolidated motor inactivity that might be indicative of sleep. And you know, sleep researchers have been using wrist-worn accelerometers to characterize sleep and wake for a long time, as you can tell from the quality of this printout. So you could see something. Looks like maybe there's a pause that might be reflecting sleep in this 11:30 p.m. to 12:30 a.m. time. And then this is someone without dementia, just for illustrative purposes. This is what a sleep window might look like. And we have algorithms that actually, it's not just a matter of eyeballing that lets us determine from actigraphy data such as these, whether someone is asleep or awake. There are algorithms that we use that have been validated against polysomnography for this purpose. So just a picture to illustrate what we see in people with AD. And so the mechanisms that might account for this include loss of brain volume, certainly in the suprachiasmatic nucleus, that central clock in the brain, and in the intermediate nucleus. And, you know, sometimes this image doesn't come out right, but it's basically showing that, I'm going to skip over it, but reductions in that brain region, those brain regions, and then reduced exposure to bright light. Light is it is the principal Zeitgeber, right? There's that term that synchronizes our sleep-wake cycle and all of the clocks throughout our body. We have clocks in all of our cells, which is something we didn't know for a long time, but we do. And this is the master clock, the SCN. So exposure to bright light is what entrains all those clocks with the light-dark cycle, all right? And older adults might have, particularly those with Alzheimer's disease, have less exposure to bright light, in part due to their disabilities. And so that can account for poor sleep in AD. Also, reductions in daytime activity and increases in time spent napping, as we discussed previously, and alterations in the cholinergic system, which we know is affected in AD and can affect sleep. In an AD mouse model, it turns out that the clinical impression of, care providers who sort of informed the initial conceptualization of the link between neurodegeneration and sleep disturbance, we see this recapitulated, if you will, in this mouse study, all right? So in an Alzheimer's mouse model, Rowe et al. From Dave Holtzman's group in WashU showed that as amyloid plaques accumulate, there is a concomitant alteration in the sleep-wake cycle. And furthermore, when they performed active immunization on these mice using A-beta 42, they prevented those sleep-wake cycle alterations. So yes, AD pathology negatively affects sleep. And so it's not surprising that this was sort of the way that people thought about this for a long time. I started doing a postdoc in 2003, and around that time, there started to be a bit of a shift in how people were thinking about sleep and cognition and brain health, because there were studies showing that in relatively healthy older adults, we would see links between sleep disturbance and, even if it was a self-report measure of sleep disturbance, and cognitive performance and cognitive decline, okay? And so that raised the possibility of, maybe this is a risk factor that might play a role that may be modifiable. And then in 2009, there was a seminal paper that was published by Dave Holtzman's group, and it showed, again, studies from WashU, that if you sleep deprive an Alzheimer's disease mouse model, you get greater amyloid deposition, which you see these dark bars reflect the amount of amyloid plaque burden in sleep-restricted mice versus controls. And you see markedly greater amyloid deposition. That was one of many fascinating findings from that study. But that really blew people's minds, to put it technically. It opened up and spurred a lot of other studies. So this was really a sort of a watershed moment in the sleep and Alzheimer's disease period. And this is the year that I got my K Award. And I actually partnered with Mark Wu, who is a neurologist and a geneticist and a sleep medicine physician in neurology here. And we got a Brain Sciences Institute grant from Johns Hopkins to study links between, in like 2010 or 2011, to study links between sleep and amyloid in older adults with mild cognitive impairment and in fruit flies, in Drosophila. Because Mark, back then, he does mice too, but Drosophila are a fantastic organism to study sleep in because they're relatively simple and they've really well characterized their genome. And there's an Alzheimer's model, and they sleep at night like we do. They are not, they're not nocturnal like mice. And so in a study led by one of his mentees, Masashi Tabuchi, we showed that if you sleep deprive a Drosophila model of Alzheimer's disease by shaking the tube in which they reside, okay, at night, right, and disturb their sleep that way, you get how much? This much amyloid plaque. That's the bright green. It's immunostained for amyloid. If you shake it during the day when they're awake anyway, you get this much. So more evidence for a potential causal link. Granted, these are in animal models. But this work really got people wondering about, could it be that the arrow goes in the other direction, that sleep-wake disturbance might be a cause or contributor to neurodegenerative disease? And at that time, in 2013, Mark and I partnered with folks at the NIA Intramural Research Program, Baltimore Longitudinal Study of Aging. Many of you are familiar with that. And we published what was the first study of self-reported sleep and imaging on PET scans in older adults in a community-based sample. And this was in 70 participants in the BLSA, 76 years of age on average, about half women, almost 20% African-American, highly educated, as is always the case, it seems, in the BLSA, in good shape cognitively. They self-reported their sleep, and then within 5 years after that, they had an amyloid PET scan with Pittsburgh compound B PET. And we showed that reports of shorter sleep duration were associated with greater amyloid deposition on a cortical distribution volume ratio, the CDVR, which is a global measure of amyloid deposition. And also, shorter sleep was associated with greater deposition in the precuneus, which is a region in which amyloid deposits early in the AD course. And we also found that reports of worse sleep quality, more restlessness at night during sleep, was associated with greater amyloid deposition in the precuneus. So that was really exciting. What we're showing on the right half of the page here is each of these columns represents brains, sort of strata of brains of people with a particular sleep duration. The leftmost is people who get the longest sleep, more than 7 hours. The middle is something like it's greater than 6 to less than or equal to 7. And then 6 hours or fewer here. And you can see more hot colors as you move from left to right in that image that's unadjusted. These analyses were adjusted, however, for a range of potential confounders. So now I'm going to shift gears. And so now we've linked sleep to amyloid, an important step, right? Now I want to talk a bit about sleep-disordered breathing and show some work that I did a bit earlier than this with colleagues at UCSF during my second postdoc. Yes, some people do more than one postdoc. So sleep-disordered breathing is characterized by repeated interruptions in breathing during sleep, right? Complete cessations of breathing are referred to as apneas, and decreases in airflow with accompanying desaturation of blood oxygen, hypoxemia, are referred to, or arousal from sleep, are referred to as hypopneas. And obstructive sleep apnea, or OSA, is the most common subtype of sleep disorder breathing. And the risk factors for OSA are age, older age, higher BMI, greater neck circumference, and male sex. And we get the gold standard measure of sleep is polysomnography, right? And so from polysomnography, we get the apnea hypopnea index, which is the number of apneas plus hypopneas per hour of sleep. And it gives us a sense of the severity of sleep disorder breathing. And it's highly prevalent in older people. Depending on where you look, you can get pretty wildly different numbers. But this study by Young et al. Showed 60 to 99. Among people aged 60 to 99, about 20% had sleep disorder breathing. But another study by Ankoli Israel and colleagues in a sample from San Diego, a community-based sample, showed that, might have even been population-based, showed that as many as 62% of adults age 65 and older have sleep disorder breathing. Again, it depends on the threshold you use as well, but needless to say, it's common. And so when I was a postdoc, the first paper I published working with Christine Yaffe at UCSF was in the study of osteoporotic fractures, which is an observational study of women who are predominantly white. And it's really a study of the natural history, risk factors, to identify risk factors for and outcomes of osteoporotic fractures. But they had really broad inclusion criteria, so it became just a wonderful cohort to study aging. And they added sleep measures, really good sleep measures. So we studied 448 women in this study with a mean age of 83. And they completed in-home polysomnography. Their average AHI was 15.5, and that indicates moderate sleep disorder breathing. Anything from 15 and up indicates moderate to severe sleep disorder breathing. And what we found, if you look at these outcomes, is basically for every standard deviation increase in the apnea hypopnea index, we saw 40% greater odds of cognitive impairment on the MMSE. And in people who had severe sleep disorder breathing, this AHI of 30 plus, they had, compared to those with lower severity of AHI, they had 3.4 times the odds of impairment, which was what impairment was defined using the pseudo MCI criterion of 1.5 standard deviations below the mean, mild cognitive impairment. So that was pretty exciting. And then a subset of these women had ApoE genotyping. ApoE, of course, is the strongest genetic risk factor for Alzheimer's disease. And we found that the association was much stronger between the AHI and impairment on the MMSE among ApoE4 carriers. Interestingly, we didn't find anything for trail making test B, but I have some thoughts about why that might be. If we have time later, happy to tell you about it. And then I was, after I moved to Hopkins, Christine led this paper that actually became a very important paper in the field. I'm very pleased to have been on it. Grateful. So this was a study in the same cohort of almost 300 women with a mean age of 82. And basically 35% had moderate to severe sleep disorder breathing in this sample. And what we found later on was that compared to those without sleep disorder breathing, this reference category, those with had 1.9 times the odds of mild cognitive impairment or dementia 5 years later. So that was pretty exciting. And to go over this part quickly, just for time, we found that measures of hypoxemia seemed to be driving that association. It didn't seem to be other potential sleep consequences of sleep disordered breathing. We know sleep disordered breathing breaks up your sleep. It didn't appear to be sleep fragmentation that accounted for it. We know that you can end up with shorter total sleep time because of sleep disordered breathing. Didn't seem to be sleep duration, seemed to be hypoxemia. So very interesting. And then moving to some structural brain imaging work that I partner with BLSA folks. We looked at association of, they happen to have from way back when in BLSA, a measure of sleep duration. And so I said, wow, can we link that to all of the great MRI data that you have? And so these were BLSA participants who were 67 on average when they reported their average sleep duration. And then they subsequently completed 7.6, an average of 7.6 MRI scans, right? And between 3 and 11 of them over 8 years on average. And we followed them until we only included imaging from when they were cognitively normal, all right? So they're all cognitively normal throughout all the data that you see here. And we looked at repeated measures of cortical thickness as our outcome. And we found that compared to people who reported getting 7 hours, because of the distribution of the data, we divided it into 7 hours, less than 7 hours, more than 7 hours. And compared to those who reported 7 hours of sleep, those who reported fewer than 7 hours had more rapid cortical thinning in all of these regions. And they were almost all in the left hemisphere. I'm not sure why. Confession, I really don't know. But we thought that was pretty interesting. And then we looked at longer sleepers, those who slept more than 7 hours versus 7 hours. And we saw a more rapid thinning in these frontal, by the way, these were frontal and temporal regions. I don't recall if I said that. These were just in frontal regions, which was interesting, and also left hemisphere. And this is a pretty picture showing the results. But we thought that was pretty fascinating that we could detect that. The effects aren't necessarily humongous, but keep in mind, these people were cognitively normal through all these scans. So that might account for that. So this is all to say that maybe there are some links between, maybe in this direction, between sleep-wake disturbance and neurodegenerative disease. The thinking now is really that this is a bidirectional association. And I'm going to say more about that. The big question that you might be asking is, well, how does this happen? What is the mechanism, right? And this is a paper by Yoel Ju and colleagues, also from WashU. They've been doing some of the best sleep and Alzheimer's disease work for a long time now. And what they posited is that poor quality sleep, if your sleep is broken up or for whatever reason, you will have reductions in slow wave sleep. Slow wave sleep is believed to play a really important role. This is where you get into the real neuroscience-y part, in downscaling neuronal activity. We tend to think about neuronal activity as being a good thing, right? Well, I want my neurons to stay active. Well, sure. But if you have excess neuronal activity, you actually end up with some excitotoxicity, which can lead to increased A beta release. We think there's Cirelli and Tononi have years ago put together this hypothesis called synaptic homeostasis hypothesis, which states that slow wave sleep, from the time that we wake up in the morning until we go to sleep at night, we are navigating our environment and forming connections and strengthening connections between neurons, building synaptic strength. And the theory holds that slow wave sleep in particular, based on a lot of evidence, downscales that synaptic strength, sort of gives you a reboot. And if you don't get that, you have a net excess of neuronal activity that leads to A beta release, increases brain interstitial fluid levels of A beta, and leads to plaque formation. And then that feeds forward to affect regions that control sleep, leading to further deterioration in sleep quality. We talked about sleep disordered breathing. Let's move to the other side of the figure here. Sleep disordered breathing can, as we were talking previously, I mentioned, it can lead to a disturbance in your sleep consolidation. It can fragment your sleep. So you can, through sleep disordered breathing, end up with more A beta in your brain through this pathway. But then also, hypoxia, we know, increases the likelihood of plaque formation, and inflammation is a major consequence of sleep disordered breathing. It's a consequence of just poor sleep in general, but it's a major problem in sleep disordered breathing that we think gives you, so this gives you basically two routes by which you might end up with more amyloid. Another mechanism that we have to mention is the glymphatic system. So you've heard of the lymphatic system, which helps clear out, toxins in the periphery. Well, they used to think, by the way, that there was no lymphatic system in the brain. And so they said, because they identified this system that I'll describe momentarily, that's really modulated by the glia, They call it the glymphatic system. So what Xie et al. In Make and Nadergaard's lab showed in 2013, that during slow wave sleep, there is greater clearance of A beta from the brain. If you inject A beta into the brain in mice and induce sleep using an anesthetic, or you just let them sleep naturally, during slow wave sleep, you get more efficient flushing of those toxins from the brain. And this is through an expansion of the interstitial space. And it's like a dishwasher-like effect that occurs, and it's being studied a lot. And we think that sleep really activates this system. So that's another mechanism by which. And so if you're not getting your slow wave sleep for whatever reason, or getting insufficient slow wave sleep, that's another way that you might end up with more A beta in your brain. So, so this is the way that people are talking about this link. It's really bidirectional. And we've been showing, I'm very interested in this association from sleep-wake disturbance to neurodegenerative disease because of all the implications for prevention, right? But these days, I've become increasingly interested in what modifies these associations. It's unlikely that this is going to act consistently in this manner, or that the associations would be of the same magnitude across populations. So what are those moderators? What are the factors that might actually interact with sleep disturbance to affect or buffer, affect negatively or buffer AD risk? So my former doctoral student, Jocelyn Owusu, she led a study in the BLSA looking at the interaction of sleep and race on cognition. And what she showed was that indeed, in a cross-sectional analysis, that there was a significant interaction, as you can see here, between wakefulness after sleep onset and performance on a memory test, such that, and this was in, I'm trying to think how many women it was, or this is in men and women, but they were age 73 on average, 22% Black, identified as Black. And what we found was the association was stronger and statistically significant in the Black women, such that basically the association between wakefulness after sleep onset, sleep fragmentation, and cognition was stronger among Black, this actually, I keep forgetting and thinking it's soft, among Black participants, whether they were men or women. And also, longer sleep onset latency was associated with lower performance on visual spatial ability. Sleep onset latency is the amount of time it takes you to fall asleep, all right, after you attempt to sleep. And so that was really interesting. And we wanted to look at race because we know that there are disparities in AD by race and in sleep. Actually, and there are some investigators who are very actively investigating sleep disparities in sleep health as drivers of other health disparities. What about other risk factors or protective factors for dementia? Daniel Callow, depicted here, has been studying this in various ways in the BioCard cohort. And he is a fellow in psychiatry, working with Arnold Bacher. And so we looked in, I'm trying to move stuff around on the screen. In the BioCard cohort, in 157 older adults who did not have dementia, with a mean age of 72 years. And they wore wrist actigraphs, accelerometers for 7 24-hour periods. And here you see some results from cross-sectional analyses. We wanted to look at total volume of physical activity. There it is, I think. Here it is. These are independent associations of total volume of physical activity with cognitive performance, with performance on a global cognitive test. And you can see that greater TVPA was associated with better performance. And sleep efficiency, higher sleep efficiency, was also independently associated with better performance on this global measure. Total sleep time was not, interestingly. But what we found was, it's a little bit cut off here. but there was an interaction between physical activity and sleep efficiency. Remember, sleep efficiency is the proportion of time in bed that you spend asleep, such that the association between total volume of physical activity and global cognitive performance was strongest among those with the poorest sleep efficiency. So those with the poorest sleep stood to, if there was a causal association, stood to benefit most cognitively if they had higher levels of physical activity. So that was interesting. And so everyone in this room is probably interested in interactions of sleep and hearing loss on brain health. And I have to disappoint you, I am not going to talk about that. But if you come to Kining Zhang's thesis defense seminar on Monday, March 24th from 9 to 10, you will learn a lot about that. And her slides will be much prettier than mine. She makes these great slides. And actually the ones that I'm going to show you now, oh, and I have to give Daniel Callow thanks for the slides that he provided me. Thanks, Daniel, if you're watching. Much appreciated. And thank you, Kining, for these slides. So I want to go over just a couple of studies that Kining has led. She has really carved out a niche of her own in this field, looking at links between sleep disturbance and hearing loss. This was a study that she led in NHANES, and this was in 632 participants who were age 70 and older in NHANES 2005 and 2006. This is cross-sectional, but they had their hearing measured in a sound isolating booth as part of their participation in the NHANES mobile examination centers. And pure tone average was calculated for both ears as the average of the hearing thresholds at different frequencies. Okay, and there was a calculated speech frequency, pure tone average, as well. And so these participants were asked what their the number of hours of sleep that they usually get at night. And Kining leveraged these data to get some really interesting results. She found, after performing a multivariable adjusted regression model employing a three-piece linear spline at less than 6 hours, with no less than 6 hours, 6 to 8 hours, and more than 8 hours. She found that across frequencies, when we look at the group of participants with the sleep duration above 8 hours, I'm really bad at this. So that is above here, that you see basically across all of these frequencies that longer sleep seems to be associated with poorer outcomes. And after what was perhaps the most striking finding was here for high frequency PTA, each additional hour of sleep went among people who slept more than 8 hours was associated with poorer high frequency hearing on the order of about 3 decibels higher, which is really impressive. And I think I have some other notes here. Thank God for these speaker view notes, but I think because of time, I'm going to go to the next study. Kining has been prolific, so I want to get at least a couple of her studies presented here. And then this one was a study in the ERIC cohort that overlapped with participants who were in the sleep heart health study. All right. And so these participants in 1996 to 1998 self-reported various aspects of their sleep, including sleep duration, and completed the Epworth sleepiness scale to get at excessive daytime sleepiness, and they completed polysomnography in their homes. And the outcome here was, remember, I said 1996 to 98. The out was the exposure. The outcome was 2016 to 2017. So pretty impressive. What did she find? Well, although it wasn't statistically significant, if you look on this left side, there was a similar magnitude. Do you remember the 2.9 that we saw in the last study for each hour increase in sleep duration in NHANES? Well, she found approximately the same, very close results here if you just examine the point estimate for high frequency audiometric hearing. If you look at speech and noise performance, however, we did find that among those whose habitual sleep duration was more than 8 hours, those who had longer sleep duration had lower performance on the quick speech and noise test. So that was certainly interesting. And there were other findings as well that again, these are the Kinning slides. Thank you again, Kinning. Aside from that, she found that rapid eye movement sleep, which is really important for various aspects of life, including cognitive performance. She saw associations of more time in REM sleep with better speech and noise performance. And she also found for sleep disordered breathing that there was a really strong association of, it was basically following the same pattern. There was an association there. It became, I'm trying to think, you'll have to correct me, Kinning. The REM sleep one, I believe, after adjustment for cardiovascular factors became, I think, borderline significant, but was of approximately the same magnitude. I think maybe for the sleep disordered breathing one, as you say here, it's there was a more significant attenuation of the association. And so that would imply that there is potentially a mediating role of cardiovascular risk factors. And then she also found that excessive daytime sleepiness was associated with poorer performance with speech frequency and low frequency hearing, which is, overlapping with the sleep disordered breathing findings. Not surprising, because people with sleep disordered breathing will often have excessive daytime sleepiness, although excessive daytime sleepiness is not specific to sleep disordered breathing. We've all experienced, people can experience excessive daytime sleepiness from various causes. But so I'm going to wrap up 2 minutes over by asking about mechanisms. Well, I lied. There's one more slide after this, I think. But so we can talk about these mechanisms, and I'd love to hear your thoughts. And I told Kinning at the beginning that I'm very glad that she's here, because she'll be able to answer questions that I can't. But cardiovascular risk factors and disease might account for this association. We know that sleep disturbance is bad for your cardiovascular health. In fact, the American Heart Association, it used to be Life's Simple 7, and in the last couple of years, they made it Life's Essential 8, adding sleep to the mix, which is great. Also, snoring. Snoring is a form of noise exposure, so some people think that perhaps that actually can play a role. Hypoxemia, could certainly play a role, and then inflammation as well. And while I'm talking about, we have fantastic studies ongoing and completed looking at the effects of hearing intervention, right? And it turns out that we don't have as many studies looking at the effects of improving sleep on cognition or on AD physiology. They're starting to emerge. My colleague, Brendan Lucy, who's leading some sleep data collection now in ERIC, NCS, he showed in a small trial of a drug that suvorexant, which is a dual orexin receptor antagonist. It blocks orexin and induces sleep that way. He showed in 38 middle-aged adults with no cognitive impairment who were randomized to a couple of doses of this drug versus placebo. And then he got them connected to a lumbar catheter where they sampled CSF every 2 hours for 36 hours. And they showed that suvorexant markedly decreased tau phosphorylation and amyloid concentrations in these healthy, relatively young people. So this is, of course, there's a whole other literature that shows that sedative hypnotic medications, such as, the older school medications, might be risk factors for dementia. So, but that's one of the important things. We don't know how sleep medications might play a role here. And we don't really know much about sleep medications and hearing, but that's something that Kinning is looking into in another study. This is all to say there is hope for sleep interventions to have positive effects on Alzheimer's disease. And designing a trial is tough for various reasons that we can discuss. But sleep, in many ways, some of the problems with establishing sleep as a risk factor for Alzheimer's disease, it shares some similarities with hearing in terms of, is there a shared cause of hearing and hearing loss and cognitive impairment and decline? Maybe we can learn some lessons from the hearing folks to sort of raise our profile. We're trying in terms of AD risk factors. I want to thank all of you for your attention. I want to thank NIH, particularly NIA, for supporting my work And my co-authors, collaborators, and research staff, Daniel Callow and Kening, for sharing slides and just being great people to work with, all of my trainees, and participants in the various studies from which data was presented. Thank you.
And I have so many questions.
Okay.
And I want to monopolize it. I really, really do though.
Okay.
So, maybe a few rapid fire ones.
Okay.
So at the very end, like, that drug was called, shows may enhance like essentially T-tau. But even there's been a lot of flurry of these other drugs that apparently the aortic valve action, you don't get like lymphatic clearance and like that, right? So it's just a completely different mechanism of how those drugs are working, or it's still too early to say.
Well, so it's interesting. We don't know 100% that it's lymphatic clearance. That's one of the things that's very interesting, right? There are really these two competing theories. One is the lymphatic one. The other one is this synaptic downscaling, and that is really playing the role. And both of them, however, are dependent upon modulating slow wave sleep. That's the thing they share. But yeah, it's a good question.
All right, so then so if you had to pick like in your gut, like the best quote biomarker of sleep that matters. Rough guess, sleep efficiency, slow wave, like what do you think?
So I think that it really depends what your question is.
The goal basically being you have that biomarker, you quote better sleep by that biomarker, and it leads to positive effects on health and brain health.
I think that slow wave sleep would be very important. I think the problem is sleep is multidimensional. So you can look at things so many different ways. In fact, so Dan Bicey, who is renowned, he was the first author of the Pittsburgh Sleep Quality Index that everybody has heard of probably. And he came up with a concept of multidimensional sleep health that really looks at many different aspects of sleep and advocates that we do that rather than focusing in on these either disease categories or individual dimensions of sleep, that we really have to consider things together. Part of the reason being, what if you get, so first of all, the slow wave sleep, is it amount of your slow wave sleep that you're getting, or is it the percentage of your total sleep time? We think that there are probably aspects of sleep that play a role in your brain health. For example, I can tell you, Yue Lang from UCSF, a collaborator, a colleague, she had a paper that recently was published that showed that it really seemed to be delayed REM sleep onset. If your REM sleep is pushed back too far, that is linked to AD. So I don't know that we've focused on slow wave sleep. I don't know that it's the only, I don't think we know enough yet. But
I was one last question. Sorry. I'll come back. So I'm so surprised at the very end you said there's not like been like some type of decent intervention-based trial to show that sleep matters, which intuitively it makes sense. So let me ask you thoughts on this one. So let's say you're a clinical psychologist. You see a patient, they're like, Dr. Spira, I'm really worried about my sleep. How would you begin the coaching phase of getting better sleep? Is it like formulaic or is it not formulaic?
So I'm so glad you teed that up, because oh, sorry, Dr. Spira, you guys are so respectful. So, if you have someone as a clinical psychologist, I haven't seen a client, patient, consumer, whatever you want to call someone who comes in for, I haven't seen one in many years, but I do maintain my license. But how would I treat someone who came in with a sleep disturbance? So sleep can be disturbed by many, many things. I'd be curious about factors such as sleep disordered breathing. Is that something that's leading to it? But if it is insomnia, and imagine there's no sleep disordered breathing, by the way, those things do often go together. There's even a category called COMISA, COMISA, comorbid insomnia and sleep apnea that people are studying. So if someone just comes in with insomnia, I have trouble falling asleep, staying asleep, my sleep isn't restorative. There is the American College of Physicians, I believe in 2016, published a position statement recommending cognitive behavioral therapy for insomnia as the first line sleep treatment for chronic insomnia. It's so well established as an intervention. There's massive evidence, and it's not every day that the American College of Physicians recommends a psychotherapy as the first line treatment for it. So, that just sort of was very nice to see. And that is available through providers around the country. The VA, maybe 10 years ago, really hired a lot of psychologists because we actually see in veterans a lot of sleep-related disturbances to train them in CBTI, as it's known. And there are digital versions of CBTI that are available through apps such as Sleepio. I don't make any money if I tell you these names. And insurance companies will pay for some of this, I believe. And so, and there's a great push to get it out of PhD level providers, so they are training all sorts of allied health professionals in delivering those interventions. But conventionally, it has been psychologists. Yeah. So that was my answer to that.
One question, I'll pass you on to someone else.
No, I love it. It's a
For CBTI or CBT, right? Is part of it a lot like just basic sleep hygiene stuff, like
So,
lighting and all that sort of stuff?
great question. It is for chronic insomnia, it's established that that sleep hygiene is a necessary but insufficient component. It actually has two primary components. Sleep restriction is one of the things that which sounds counterintuitive, and stimulus control are the two core components. And then there's a cognitive piece that some people say is not really for most people, the main problem. But people have catastrophic thinking or worry about their sleep that perpetuates arousal that interferes with sleep, et cetera, et cetera. So that's the short version. But yeah, Moises, good to see you.
Excellent presentation.
Thank you.
It's not my area, okay? But in terms of the sleep abnormalities, comorbidities other than cardiovascular disease, particularly those that cause pain.
Mhm.
You know, as people get older, they start having like osteoarthritis, like I do.
Yeah,
They have to use a cane.
yeah,
And so, you know, cancer, metastatic cancer,
Yeah.
people may live very long now. Life expectancy has changed a lot. The other thing is medications, okay? And so one study in which they adjusted for antidepressants,
Mhm.
sleeping pills, and something else, benzodiazepines, okay? But there are many more medications that cause sleepiness and it may affect the results of their evaluation.
yeah, you're right. You're
For
right.
example,
Oh, sorry, I'm not repeating questions. My bad. I just looked at the chat.
I don't think they heard what I said, but that's okay.
But well, the first one was about pain, the role of pain as people get older, and the second one was about all the comorbidities and medications that might affect sleep aside from benzodiazepines and so on. I think it's a great question. We don't know about that. So talking about pain, Michael Smith in psychiatry here did a randomized trial of CBTI in people with osteoarthritis and had positive results. So that's something to think about. And actually, it's been replicated, I believe, by Michael Vitiello's group in University of Washington. So actually, and one of the things that's very interesting is that sleep modulates pain nociception. So it's very interesting. If you sleep deprive people, they are subjectively more likely to report pain based on the same objective stimulus. It's a fascinating thing. So improving sleep will actually improve pain. The question about medications, I am really concerned about all of the different medications that people take in terms of their effects on sleep. We have studied various antidepressants and benzodiazepines and so on. And we have a general sense, but how they interact to affect sleep is very interesting. We have new classes of medication like these DORAs, these dual orexin receptor antagonists. How do they affect sleep versus other classes of medications? And we see links to dementia with some medication classes and outcomes, but we don't know we don't have good ideas of what the mediators are.
Well, one final, the correlation between the biomarkers. Because there could be interaction between them as well.
Oh, yeah, you mean the various, yeah.
Different markers or sleep abnormalities.
Yes.
What is the correlation?
They're correlated. They are. But the thing that's troubling, so this is one of the reasons we can't focus on just one. Sleep duration there's been a lot of focus on sleep duration, right? And actually the Lancet Commission, they focused mostly on sleep duration in their evaluation. And there are many aspects of sleep that you can focus on. But you know, we often see a U-shaped association, like, and which is why we examine it like Kinning did, for example, or like I did in the cortical thinning paper. It's hard to interpret any sleep. It's hard to interpret wakefulness after sleep onset without knowing something about how long people are sleeping, right? And then if you look at someone's sleep duration as measured by self-report or actigraphy or even polysomnography, until you get some information about what's their sleep disordered breathing like, you don't get the full picture. So it's very hard to narrow it down to one. And we do not have we don't have a good blood biomarker of sleep deprivation. That's what we really, if we had that, that would be very helpful. We don't. Yeah, Jason.
Yeah, this was like a really interesting talk, so thank you.
Oh,
I
thanks.
still have a couple like etiologic questions. Do we select the impaired like amyloid claims? That all makes sense to me, but do we know whether sleep's associated with other like important etiologies that are giving rise to like the clinical dementia expression, like hippocampal sclerosis?
So that's a good question. There are studies looking at hippocampal structure, comparing in people with insomnia and without. There are people, and then in diagnoses such as post-traumatic stress disorder, there's a lot of comorbid stuff that goes on there, aside from sleep disturbance, looking at hippocampus. We do have studies linking to hippocampus, but not necessarily specific to AD. You know what I mean? They don't necessarily, that's
separate, kind of like.
Yeah. Yeah.
And then
Yeah.
what about like, does it also impact maybe clearance of like Lewy bodies? Is that something that's been investigated?
So that's a very interesting question. So Lewy bodies, there are links now. There's more research coming out linking sleep disturbance to Parkinson's disease. In Lewy body dementia and people who develop Parkinson, in the synucleinopathies in general, we know that there is a sleep disorder that is associated with a substantially elevated risk of developing one of those. Thank you for whoever's typing in the chat. And REM sleep behavior disorder, or RBD, is sort of a bellwether for future risk for synucleinopathy. What we see in people who so usually during REM sleep, during which we do most of our dreaming, our skeletal musculature is paralyzed. It's one of the hallmarks of REM sleep, and we detect it on the through an electromyogram on the polysomnogram. There are people who do not have sufficient suppression of their sufficient paralysis of their skeletal musculature during sleep, and they act out their dreams. And it's actually can be quite dangerous for them and for their bed partners. There are people who cannot sleep in the same bed as their spouse because there is such ballistic activity, I believe is the term that they use, because people, and there are videos that you can see of people really showing complex behaviors, like getting on top of their bed and digging holes because that's what they're dreaming about. It's really, it's very disruptive and concerning and potentially dangerous, but more importantly, it predicts years and years out in some people, Parkinson's disease and Lewy body dementia.
Like in terms of prevention too, so do we know like whether or not midlife sleep issues or sleep disturbances are, maybe associated with amyloid, like impaired clearance of all of these different histopathologies earlier on in like the disease course?
We don't know. We do know that a single night of sleep deprivation in middle-aged people, in younger or middle-aged people, does show effects on PET scan. There was a study, Nora Volkov from NIDA was senior author on it. Shokri Kajori, I think, was the first author. But then so it's showing that you can actually use sleep-deprived people, you can detect effects on a PET scan. The Brenda Lucy story, the study that I showed you, improve sleep with this drug, and you improve, improve tau phosphorylation and amyloid production. And then the other one, there are studies. I think time in the life course is really important. For example, cardiovascular risk, looking at AD, right?
Yeah.
So I can tell you that there was a study that was published by Sabia et al. From the Whitehall study of civil servants in the UK. And it showed that really the effects were really the strongest in people who were age 60-ish. And as you get older, the effects are lesser. So it was like, maybe it was 40 to 60 or 60 to, it was basically more of a midlife time than in older adulthood.
Like, would you expect the effects of like sleep and vascular disease to be additive or like?
Or synergistic
additive,
even.
like, synergistic way?
Potentially, yeah. And that's one of the things that we hope to learn. Yeah.
I hate to cut this conversation short. There's been so much great discussion and absolutely outstanding presentation. Thank you so much.
Thanks for
Really
inviting
appreciate
me.
you, yeah, us today. Unfortunately, we are out of time. And so thank you again to Dr. Spira, and we look forward to seeing everyone again.
Thank you. Should I leave the Zoom? Is that okay?
Yes.
Leaving.